For special relativity, Einstein provided a thought experiment about how time slowed. This is when as a space traveler would increase her speed in space. Explained, as the rocket ship moved away from Earth, time slowed for its occupant. The popular example is to imagine flying in a spaceship where when moving fast enough it will alter its space and time. Now imagine in the spaceship a light clock which stands vertically or perpendicular to the direction of the ship. Consider the duration of the light clock as x, and z as the direction of the ship. For example, x is 90 degrees to z, which is at 180 degrees. A full cycle of the light clock x occurs when it bounces a beam vertically from its top point AC to its bottom BD and back, i.e., marking a period of time. Consider for a second in time, the interval for the light clock takes 1/2 second between points AC, or its top, and BD, or its base. If velocity of the spacecraft in direction z is at 0, then the beam bounces vertically at 90 degrees with respect to z as marking time. This applies for both an occupant of the ship and a separate observer. It would further appear at 90 degrees if both observers were in a parallel constant momentum. If velocity of z, the rocket ship, is increased, then the beam of light is considered proportionally delayed between its points. Depending on velocity, x can appear as a sine wave where points AC and BD represent half the wavelength in amplitude. When the beam returns round trip from AC to AC, it is considered a unit of its frequency. Hence FQ equals amp, vel. Given an amplitude amp and a velocity z, we have frequency FQ. Amp, Vz equals FQ. This is where FQ*vel z equals amp,